Hello, students, and welcome to School from Home Wednesday. We're going to start by looking at our Do Now, where we answer a prompt about group dynamics or the interactions we have when we're together as a group. We will continue our work with order of operations, and we're going to be asking what is the correct order of operations. Why is order of operations important, and how can I remember the correct order of operations? As we watch the video, we will complete, I believe it's 12 problems on order of operations. They could be a little tricky, so be careful and look at them carefully. We'll have an exit ticket where we answer complete two thoughts. When I work with multiplication and division, how do I work? And when I work with subtraction and addition, how do I work? And remember, you're going to show your work to me or send me a picture in an email. If you did not get a chance to finish your lesson, still show it to me, but you can finish it for homework. To get full credit, we're going to have our camera on. Respond when your name is called at any point during the period. Show your work. Super important. You have to show Mrs. Gold what you've been doing this period. And if you have any questions, please email me. So Friday coming up is our superhero day, where you get to represent a real or fictional superhero. Now, group dynamics, what is that? Well, it refers to the behaviors and processes that occur in a group. So how people are with each other. So how has the COVID-19 pandemic altered the group dynamic of the classroom? What things are the same? What things are different? Are some of the things better? We've talked a lot about some of the negative things about COVID-19, but there are some things that might be a little bit better. I think some of you are becoming more independent learners, for one. I think that we could work together a little more, and we've gotten away from that, so we're not doing group projects. So I'm hoping next year we all get back to that, because those are great as we do learn from each other. But I think we're also learning how to learn from each other in different kinds of ways, just by listening to each other when you share during a class or a Teams call or anything like that. So please respond to this prompt and put your thoughts right below there. We'll come back to our exit ticket in a couple of minutes, but let's get started with our order of operations. Okay, this was originally meant as a homework, but I think it's a great set of problems, and I think it's great classwork practice. So that's what we're doing with it. So we only have subtraction and multiplication. Well, addition and subtraction are worked from left to right. Multiplication and division are worked from left to right. Let's actually review for a minute before we even get into this problem, the order of operations. I gave you kind of an acronym to help remember it, which is GEMS, and that is grouping symbols, exponents and radicals, multiplication and division, and multiplication and division. All of it is to be done before subtraction and addition. Now let's talk about grouping symbols. They are absolute value bars, parentheses, brackets, braces, not the kind you wear on your teeth, the vinculum in a fraction. So if you have A over B, or if you have 3 over 4, this line, the vinculum, is also a grouping symbol. And the division house, the old-fashioned division house, and also the radicand are also grouping symbols to some extent. You have to look at the context. And then we have exponents and radicals. Do all of the multiplication and division from left to right, and then all of the subtraction and addition from left to right. And remember, that doesn't mean division can't be done before multiplication. And I hope we see in these examples, if division is before multiplication in the left to right sequence, you'll do that division first. But all of the multiplication and division must be completed in the expression and evaluated before you do the subtraction and addition. So here we have subtraction and multiplication. Well, the multiplication is 8 times 5, which is 40. So now we have 23 minus 40. Remember, when we add integers or subtract integers with different numbers, we ignore the sign, subtract, and take the sign of the number with the highest absolute value. In this case, the 40, so our answer will be negative 17. Number 2, I have addition, division, I have an exponent, and another subtraction, or a negative 17. I will start with the exponent of 3. So 16 plus 56 divided by 2 to the third is 2 times 2 times 2, which is 8 minus 17. Then I have to do this division. 16 plus 56 divided by 8 is 7 minus 17. All I have left is addition and subtraction, so I'll work from left to right. 16 plus 7 is 23, and 23 minus 17 is 6. Number 3, I have absolute value bars here, so I have to work everything inside the absolute value bars first. That is a grouping symbol. So we've got 7 squared, or 7 to the second power, minus, now I have 6 minus 2 times 7. I need to start with the multiplication within the fraction bar. So it will be 6 minus 14 times 3 to the second power. Staying inside the fraction bar, the absolute value bars, 7 to the second power minus the absolute value of negative 8 times 3 to the second power. Now, still continuing inside the absolute value bars, we'll have 7 to the second power minus, now, what's the absolute value of negative 8? Well, the absolute value of negative 8 equals 8, because absolute value is never negative, because it represents distance from 0. So that would be 7 to the second power minus 8 times 3 to the second power. Now we can work these exponents. 7 to the second power is 7 times 7, which is 49, minus 8 times 3 to the second power is 3 times 3, which is 9. Now I have subtraction and multiplication. I have to do that multiplication. 49 minus 8 times 9, which is 72. And then 49 minus 72 is a negative 23. And that is our final answer. Number 4. We have 5 times the quantity, this is a grouping symbol of 7 minus 4 with an exponent of 3 on the entire quantity in the parentheses. And all that is divided by 10 minus 1. So I'm going to start inside both pairs of parentheses at the same time. 5 times 7 minus 4 is 3. I will keep the parentheses because there is an exponent there, divided by 10 minus 1, which is 9. Now, I will do 5 times 3 squared equals 27. 3 times 3 times 3. So 5 times 27 divided by 9. Now I have multiplication and division, so I'm just going to work from left to right. So 5 times 27 is 135. I have my divided by 9, and 135 divided by 9 is 15, and that is the answer to our problem. So try the next few on your own, and then come back and check your work and see how you did. It's step by step. Okay, are you ready for number 5? 9 to the second power minus 2 to the sixth power, That is in parentheses. That's a grouping symbol. Minus the square root of 64 plus 36 divided by 3 times 4. So let's start with 9 squared minus 2 to the 6th power. So in parentheses, 9 times 9 is 81 minus 2 to the 6th, which is 2 times 2 times 2 times 2 times 2 times 2, that's 64, minus the square root of 64 plus 36 divided by 3 times 4. Now, 81 take away 64 is 17, minus the square root of 64 plus 36 divided by 3 times 4. Now, we can work with the square root of 64, which is 8, because 8 times 8 equals 64. So 17 minus 8 plus 36 divided by 3 times 4. Now the next thing I would do is multiply the 3 times 4, because then I'm going to have to divide it into 36. So 17 minus 8 plus 36 divided by 3 times 4 is 12. Now I'm going to work with 36 divided by 12. 17 minus 8 plus 36 divided by 12 is 3. And 17, sorry about that. 17 minus 8 is 9, plus 3 equals 12. That's 36. Okay, here you're going to see where it's really important to work from left to right carefully. We've got a grouping symbol, parentheses, around 9 to the 2nd power minus 2 to the 6th power, minus the square root of 64 plus 36 divided by 3 times 4. Be very careful as we work these. So let me clean that up so we can see it better. So start inside the grouping symbol. 9 times 9, or 9 squared, is 81, minus 2 to the 6th power, which is 2 times 2 times 2 times 2 times 2 times 2, which is 64, minus the square root of 64 plus 36 divided by 3 times 4. 81 minus 64, we'll start there, is 17. And we just rewrite the rest, minus 64 plus 36 divided by 3 times 4. Now let's do the square root of 64. So 17 minus the square root of 64 is 8 because 8 times 8 is 64, plus 36 divided by 3 times 4. Now, I think the next thing we'll do is we will divide 36 by 3. Remember, we're working left to right, so we're not going to multiply 3 times 4 yet. All multiplication and division before addition and subtraction. So 17 minus 8 plus 36 divided by 3 is 12. I mean to write 13. I meant to write 12. And that is multiplied by 4. We're still have to multiply. 17 minus 8 plus 12 divided by 4 is, or multiplied by 4 is 48. So 12, 24, 36, 48. You should know your 12 times tables. Now I just work from left to right. 17 minus 8 is 9 plus 48, and 9 plus 48 is 57. A little bit tricky, that one, but work hard. Go step by step. Number 6, we have 12 minus 2 in parentheses with an exponent of 2, and we have 6 times 4 minus 7 to the second power. This exponent is within the parenthesis. Look at those two exponents. They mean two very different things in the context of this problem. So we'll start in parentheses. We start with 12 minus 2 is 10, and we still have that exponent of 2 outside the parentheses. Divided by 6 times 4 minus 7 to the second power is 7 times 7, which is 49. We can start on the left. We still have that 10 to the second power, but it's going to be divided by, let's multiply 6 times 4. So that would be 24 minus 49. We're going to end up with a negative number in there. Again, let's evaluate inside the parenthesis. So 10 to the second power divided by 24 minus 49 is a negative 25. And now we'll work with 10 to the second power, which is 100. 10 times 10 is 100, divided by negative 25, which 100 divided by 25 is 4. We have a positive divided by negative, so that would be negative 4. How did you do? So try the next two and then come back. Remember, you're going to do the numerator and the denominator separately. So we have 72 divided by 2 to the third power plus 5 in our numerator, and 8 minus 2 times 5 in the denominator. So in the numerator, we have 72 divided by 2 to the third power. 2 times 2 times 2, that's 8, plus 5. And the denominator, 8 minus 2 times 5. So the next thing we're going to do is divide 72 by 8, and we're going to multiply 2 times 5. So 72 divided by 8 is 9, and then we have that plus 5. And now we have 8 minus 2 times 5, which is 10. 9 plus 5 is 14. 8 minus 10 is negative 2, and 14 divided by negative 2 is negative 7. So number 8. So that one wasn't too hard. Just do the numerator and denominator separately. So number 8, we have grouping symbols around 17 minus 11, and that is raised as a quantity to the second power, minus 3 to the fourth power. And in the denominator, we have 22 divided by 2 minus 20. So we'll start within these parentheses. So we have 17 minus 11, which is 6. And that quantity is raised to the second power, minus 3 to the fourth power, over 22 divided by 2 minus 20. Now we'll evaluate the 6 to the second power and the 3 to the fourth power. So 6 times 6 is 36, and 3 to the fourth is 3 times 3 times 3 times 3, which is 81. And then in the denominator, 22 minus, divided by 2 minus 20. And continuing on in the numerator, 36 minus 81 is a negative 45. And then we have 22 divided by 2, which is 11, minus 20. And we'll work down here. In the numerator, we have negative 45, and in the denominator, 11 minus 20 is negative 9. Now, our answer will be positive because we have a negative divided by a negative, and 45 divided by 9 is simply 5. And that's our final answer. Okay, let's move on to number 9 and 10. So number 9, in our numerator, we have 8 to the third power minus 4 times 5 to the third power. In the denominator, we have a grouping symbol. We have parentheses, and the quantity inside the parentheses is 14 minus 4 times 15, and all of that is divided by 7. So we start in the numerator with 8 to the third power. And 8 to the third power is 512. 8 times 8 times 8. Minus 4 times 5 to the third power is 125. In the denominator, we'll have 4 times 15, which is 60, and that quantity will be divided by 7. Now, on the numerator, we have to do the multiplication before we do the subtraction. So 512 minus 4 times 125 is 500. And 4 minus 60 in the denominator, because it's grouped together, is a negative 56, and that's divided by 7. So now 512 minus 500 is 12, and negative 56 divided by 7 is negative 8. And we can reduce that to negative 3/4. And that is the answer to number 9. In number 10, we have in the numerator 21 plus 3 to the fifth power divided by 9, and in the denominator, 75 minus, we have 7 plus 2 together as a quantity, and that quantity is raised to the second power. So we'll start with the numerator, and we'll work with the exponent first. So we have 21 plus 3 to the fifth power is 3 times 3 times 3 times 3 times 3, which equals 243. And then that will be divided by 9. In the denominator, we have 75 minus, and now we have 7 plus 2, which is 9, and that will be raised to the second power. So in our next step, the numerator, we're going to work this 243 divided by 9. So we'll have 21 minus 27. 243 divided by 9 is 27. In the denominator, we'll have 75 minus 9 to the second power, which is 9 times 9, which is 81. And 21 minus 27, plus 27. It was 243 divided by 9, and there's an addition. So this is 21 plus 27, which will be 48. And then we have 75 minus 81, which is negative 6. And 48 divided by 6 is 8, and a positive divided by a negative is a negative. So our answer is negative 8. And the last two problems, be very careful with this one. We've got this absolute value term at the end. It's not in the numerator or the denominator. It's added at the end. So everything here will be evaluated first before we add the absolute value of negative 27. So we'll be doing that at the end. So let's start with the numerator. We have the quantity of 13 minus 3 squared. 3 is squared, but the whole quantity is raised to the third power, minus 8 times 2. In the denominator, we have 15 minus a quantity, 7 times 2 plus 4. And then all of that is added the absolute power of negative 27. So start with the numerator. 13 minus 3 squared would be 13 minus 3 times 3 is 9. And then that all will be raised in a few steps from now to the third power. Minus 8 times 2. And in our denominator, 15 minus, we have 7 times 2 plus 4. We can evaluate 7 times 2, which gives us 14, plus 4, plus, and we can evaluate the absolute value of negative 27 equals 27, so plus 27. Now we're still working in the numerator, so we're going to have 13 minus 9 will be 4, which will be raised to the third power. Let me change my color and make this a little clearer. I want to make sure you guys see it really well. So 13 minus 9 is 4. That will be raised to the third power, minus 8 times 2, which is 16. That's the numerator. The denominator, 15 minus 14 plus 4 is 18. And to all of that will be added 27. Next step. 4 to the third power is 4 times 4 times 4, which is 64, minus 16. And that will be our numerator. Our denominator will be 15 minus 18, which is negative 3. And all of that will have 27 added. Let's keep simplifying. 64 minus 16 is 48, which is divided by negative 3, to which 27 is added. Now, we have to work with this grouping symbol. 48 divided by 3 is divided by negative 3 is negative 16 plus 27, and negative 16 plus 27 equals 11. And finally, let's go on to the one with the fractions, which I know you're not afraid of. We have a quantity in the middle. We have 8/15 plus 2/5. And then we also have an exponent on the 1/2. So the 1/2 with an exponent of 2, that is the same as 1/2 times 1/2. Okay? And 1/2 times 1/2 is 1 times 1 is 1, 2 times 2 is 4. So that's how that will play out. So let me erase that so you can see it. So we're going to start with, we have negative 5/4, and then we have that quantity in parentheses. So we're going to have to do that first. And we're going to convert the 2/5 to 15ths. So if we make this a 15, 5 goes into 15 3 times. So we're going to take that 3 and multiply it by the 2, which will make it 6/15. So left to right, negative 5/4 times, so we have 8/15 plus 6/15 minus the quantity of 1/2, which is raised to the second power. So now let's work within the parentheses. Negative 5/4 times, so 8 and 6 are 14, so that's 14/15 minus 1/2, which is raised to the second power. And let's do this 1/2 to the second power. So we have -5/4 times 14/15 minus 1/2 times 1/2. We did that up here. It's 1/4. Okay, we have to do the multiplication first. So I'm going to kind of have a little sidebar. I'll bring it over here. So that would be -5/4 times 14/15. And 14 and 15 can each be divided by 2, which we will do. And 5 is a factor of 15, so 5 divided by 5 is 1. 15 divided by 5 is 3. And this is still a -1. Now we multiply across, and we have 7. 7 times 1 is 7. That's a -7. 2 times 3 is 6. So we have -7/6. So that took care of this. Then we have -1/4. Now we need a common denominator to complete this problem. We can have a common denominator of 12. 6 goes into 12 2 times. -7 times 2 is -14. 4 can be divided into 12 3 times. 3 times 1 is 3. So now we've got -14 minus 14/12 minus 3/12. Well, our answer will be in 12ths. And -14 minus 3 is -17. You could leave it -17/12, or you could convert it to a mixed number, which would be 1, and 17 minus 12 is 5/12, and of course that would be negative. So that is our last problem of the day. We had a couple whoppers today. Slow and steady wins the race. Now remember, when you work with multiplication and division, you must carefully work from left to right. And when you work addition and subtraction, you must carefully work from left to right. So be very careful as you work one step at a time, and as you continue to practice, you'll be great.